Okay, here's an example. This is from chapter 4, section 4, number 4. I went ahead and wrote the system in augmented matrix form. Hi. So I have a leading one, so we're good to go there. I need zeros right here. So I'm thinking, okay, I need to multiply this guy by -2 to kill that guy. And so let's go ahead and do that above. -1 or +1 times -2 is -2. -1 times -2 is +2. -2 times +1 is that. -2 times +6 is -12. Now, the bottom one, I'm going to want to multiply by -3 because -3 will kill that guy. So we're going to say -3 times that row gives me -3. -3 times -1 is +3. -3 times 1 is -3. -3 times 6 is -18. Now, the row that's not changing is the first row. -1, 1, -1, 1, 6. Now, the second row, I'm going to add -2 times the first row to it. I went ahead and wrote -2 times the first row is the top. So -2 times 2, or -2 plus 2 is 0. 2 plus 3 is 5. -2 and 2 is 0. Nice. It's nice whenever we get a 0. And that -12 and 2 is -10. Okay, now for the bottom row. -3 and 3 gives me 0. 3 and 5 give me 8. 4 minus 3 is 1. 18. -18 and 4 should be -14. Okay. Now, I have a column of zeros. So now we're like working on, it's like we're working on a new problem where I have a new system with the 5, 0, -10, 8, 1, -14. So I need a leading one. So that means I need to divide that whole row by 5. So I'm going to do that. And that gives me, I'm not changing the top. Hey, buddy. Hey, buddy. Oh, that's making me write funny. Oh, you want a hug? Okay. Love you. Okay. Multiply by 1/5. And we're the same thing as divide by 5. 5 divided by 5 is gone. 0 divided by 5 is still 0. -10 divided by 5 is -2. Okay. Now I need to kill that guy, right? Now we have a leading one, so I need zeros beneath the leading one, which means that I need to multiply that by -8. Multiplying that row by -8 gives me a 0, a -8, another 0. -8 and -2 is +16. Oops, +16. Okay. Now, what am I not changing? I'm not changing the top row. I'm not changing the middle row. Bottom row is what I am changing, and I am adding all of those zeros. 8s are zeros. +8 and -8. The 1 and the 0 leave me a 1. -14 and 16 give me a +2. Okay. Now, now I'm trying to get zeros above that final one. We already have a 0 there, so that's cool. Now I just need to get that guy to kill that guy. And I'm thinking, well, that has to be a -1 to kill that. So what do I need to multiply this by to give me a -1? Well, it's -1 itself. So -1 times 1 gives me a -1. -1 times 2 gives me a -2. Now I'm just going to add those together. Not changing the bottom row. Not changing second row. Top row, though, is we're going to add that there. And so we have a 1, a -1, 0, and a 4. You'll notice I didn't even bother with these guys because they're zeros. Once we're down at this point, we're not going to even consider those zeros. Finally, I need to say, okay, what do I need to add to a -1 to give me a 0? Well, it's +1. I already have a +1. Nice. So I'm just going to take that entire row the way that he is. add it to there. And that gives me, okay, write down the rows we are not using, or that we're not changing. Add 0 to 1 is 4. -1 and 1 makes 0. 0 and 0 are 0, and 4 minus 2 is +2. And so we end up with, and since this was number 4, yes, it was X, Y, and Z. It was the X column, Y column, Z column. So this means that X is equal to 2. Y is equal to -2, and Z is equal to +2. And there's your answer. Chapter 4, section 4, problem number 2. You'll notice I've already written this in, or as a augmented matrix. And this is not the order that is written in the book, right? I noticed that one of these equations already had a leading one. And we know that we could write these in any order that we want. So I went ahead and said, well, instead of writing that one down below somewhere, I'll just make it the first equation, and then I've taken care of steps 1 and 2 in one fell swoop, right? So there we go. We have a leading 1. So now I need to get zeros right here. So the way I'm going to do that is think, okay, what plus 2 gives me a 0? Well, that will be a -2. And now that means I'm going to be adding this row to that row. I need a -2 right here, so I'm going to multiply that entire row through by -2. When I do that, -2 times 1 is -2. -2 times -3 is +6. -2 times 2 is -4. -2 times +8 is -16. Okay, I'm going to also take care of the final row too. I'm going to do this all at once, right? So I'm going to say, okay, 4, I need a -4 to kill the 4. But what number do I need to multiply 1 by to give me a -4? Well, it's -4. So I'm going to multiply this entire equation through by -4. That's going to give me -4 times 1 is -4. -4 times -3 is +12. -4 times 2 is -8. -4 times 8 is -32. Okay, so now I'm going to go ahead and add those guys. So the one that I'm not touching is the first row. So 1 minus 3, 2, and 8. Now, to kill this row, I'm adding that, which remember is just -2 times that row. I'm going to take that and add it to there. You see, I like having it written there, so there's no question in my mind what I'm doing, right? I'm just going to add those two numbers. -2 and 2 gives me a 0. -1 and 6 gives me a 5. 1 and -4 give me a -3. 10 and -16 gives me a -6. And after the bottom row, those are right there, I'm going to say 4 and -4 give me a 0. 2 and 12 are 14. -8, 9, 10, 11, -11 for that guy. Now, -32 plus 10 should give me a -22. Okay, now we have our leading one of a column of zeros. So now we are going to say, okay, we're going to pretend that this is our new system. And okay, I'm given a system, 2 equations, 2 unknowns. The first step in this case is going to be to get a leading 1 right here. How do I turn a 5 into a 1? Well, I divide by 5. So I'm going to divide this entire row by 5, like that, 1, 5. Go ahead and throw that through there. I'm not messing with the top row, so I'm going to rewrite the top row. Not messing with the bottom row yet, so I'm just going to rewrite the bottom row. Okay, now multiplying through by -5, the 0 stays 0, or I'm sorry, but 1 over 5. 5 divided by 5 is 1, like we wanted. -3 divided by 5 is -3/5. And I can see we're going to have fractions. That's okay. It's going to make work a little bit tedious, but it'll be all right. So all I did was multiply through by 1 over 5, or you could think about that as dividing everybody by 5. Okay, now I have a leading 1. I need zeros beneath my leading 1. So I need to find a way to make that 0. The only way to add something to positive 14 and make it 0 is if it's negative 14. So that means I need a negative 14 right here. So I'm going to multiply this entire row by negative 14. That's going to give me, the 0 is just a 0. I'm not even going to write the 0. Negative 14 and 1 is the negative 14. Negative 14 times negative 3 over 5 is the same thing as this. Okay, so negative 14, negative 3, that's going to be a positive 14 times 3. 3 times 4 is 12, and the 3, that gives me a total of 42. So positive 42 over 5. Okay, so positive 42 fifths. Okay, now negative 14 times negative 6 over 5. It's like the same thing, only this guy is going to look like this. Okay, so negative 14 times negative 6, we could figure out 14 times 6. Let's see, 4 times 6 is 24, carry the 2. 1 times 6 is 12, 13, 14. No, 1 times 6 is 6, plus 2 is 8. That should be an 84. Okay, so positive 84 fifths is what we have here. I've said this in class, but your paper could look as ugly as possible. I expect that you have a bunch of scratch work like this all over everywhere, like this and these guys everywhere. That's perfectly fine. That is perfectly fine. That's how you want to turn it in. That's good. Okay. So it should look a little ugly. You have to do a lot of little scratch calculations like this to do this kind of thing. So it's all part of it. So, okay, now I have, let's kind of recap. I multiplied this row by negative 14 in order to kill that 14 and give me a 0 there. So now when I add that to that, I'm going to go ahead and do it right here. So I'm going to rewrite my matrix. I'm thinking what's not changing is the top row and the middle row. So I'm going to copy those exactly. 0, 1, minus 3 fifths, minus 6 fifths, like that. Now we just need to figure out the bottom. The 0 is 0. The 14 and the minus 14 is a 0. That's why I did that. Now, here's the hard part. 42 fifths minus 11. 11, but that's the same thing as 11 times 5 over 5, right? So we have 42 fifths minus 55 fifths, which is, let's see, minus 13, right? Yeah, because if it was a minus 52, it would be minus 10, and that's 3 more, so it should be minus 13 fifths. I'm going to check it. In fact, this is what my work would look like if I were doing this on my own. I'd say, well, wait a second. Is 42 plus 13, does that give me back 55? Yeah, 55. Okay, so I got the right thing. I would have these kind of scratch work all over everywhere, and that's fine. That's fine. That's what I expect. So we have negative 13 fifths here. Okay. Negative 13 fifths. Okay. That was from the 42 plus the 42 fifths minus 11. Okay, now we have minus 22 plus 84 fifths. Why don't we write that as 84 fifths minus 22, but it needs to be over a 5. So I just multiply the top and the bottom by 5. 22 times 5. Better do this. Carry the 1, we have a 10 and 11. Okay, so 84 minus 1, 10 all over 5. Right, that's how we can rewrite that. Okay, 84 minus 110. Same thing as negative 110 minus 84. Okay, so that gives me a 10, and we could drop that down to a 10. And we get 6 here, 8, 9, 10. It should be 26. And it should be a negative 26. Let's just double check. 6/5. I'm going to say, okay, 84 plus 26 should give me 110. And so that gives me a 10, 9, 10, 11, right there, 110, check. Okay, so my paper at this point would look really ugly, right? I would have this all over the margins and stuff like that, and that's fine. You want to turn it in that way, that's cool. Don't worry about it. Okay, so we found, let's go back to it. We found that this right here is equal to that. So that's what I'm going to write there, minus 26 fifths. Okay, now, here's the tricky part. Okay, we need a leading one right here. We could think about it as a trailing one. We know that we need a 1 here because we're trying ultimately to get our system to look like this with some numbers here. If that's what we want. So let's go ahead and turn that guy into a 1. How do we do that? Well, before, when it was, say, a 5, we divided by 5. So we could say we'll divide that by negative 13 fifths. Or we could just say, so what we do, we would have some number and we would divide by negative 13 fifths. That's the same thing as multiplying whatever that number is by the reciprocal, negative 5/13. And that's another way we could see that. When you already have a fraction, you could just kind of think, well, hold up, I have some number here and some number here. And so if I multiply that number by its reciprocal, right, whatever's here goes there, whatever's here goes there, then that's going to all cancel out and give me 1. So it's another way we could look at that and just say, well, I have a fraction there. I need to turn it into a 1. So I'm going to multiply that entire thing through by, well, let's see. 5's in the denominator, so it needs to come up to the numerator. So 5. It's a negative, so it needs to be a negative. 13's in the numerator. We're going to bring it down into the denominator. Okay. All right, that looks good. We're going to go ahead and do that in the next step. Okay, so I'm going to rewrite this right here and say, okay, the top one is not changing. The middle one is not changing. Negative 3 fifths, negative 6 fifths. Now, multiply that guy across. The 0 and the 0 stay zeros. You know what that's going to be. That's why you chose that number in the first place. It's going to come out to 1. We can just double check, right? The negative 5 and the 5 go away. Negative 13 and 13 go away. Negative times a negative is a positive. And so we're left with 1. Now, this is nice. We have a negative 26 over 5 times negative 5 over 13. The 5's cancel. The negatives cancel, and we get 26 over 13, which happens to come out to 2. Just double check, multiply that guy by 2. Yeah, you should get 26. In other words, 26 is equal to 13 times 2. Yeah, so then 26 over 13 is that right there. 13's cancel, I'm left with 2. Yeah, nice. So that guy killed that fraction, gave me a 1. This guy kills that fraction and gives me a positive 2. Okay, halfway done. Now comes the easy part. Well, it's easy up until you see that we have fractions involved, but it's all right. It's all right. We're going to plug along. So I want to get, now that I'm down to here, right? I have it. This is called reduced row echelon form. Okay. And now I want to take this guy and use that to kill this guy right here. I want zeros up above this 1 now. So I'm going to say, all right, in order to get that to be a 0, I'm going to have to add, well, positive, whatever that is, positive 3/5. In order to turn that into a 3/5, I'm going to need to multiply this whole row by 3/5. So when I do that, I get a 0 and a 0 and a 3/5. And a 2 times 3 over 5 is 6/5. Interesting. Watch what's going to happen. Now, we're going to go ahead and add that to this guy right here. Let's see what we get. So I'm not changing the top row. 1 minus 3, 2, 8. I'm not changing the bottom row. 0, 1, 2. I am changing the middle row. I add the 0 to the 0, get a 0. 0 plus 1 is 1. 3/5 minus 3/5, that comes out to 0. Of course, we knew that was going to happen. That was by design. That's why I chose 3/5 in the first place. Now something interesting has happened. 6/5 plus 6/5 gives me a 0. You might be thinking, uh-oh, is that what happened there? That's fine. All that means is that y, right? This means 0 x's plus 1 y plus 0 z's is equal to 0. So this tells me that y is equal to 0. That's perfectly fine. On Monday, or very close to Monday, we're going to talk about what happens when you get something like 0, 0, 0, and then a 1 on the outside. That's a different matter altogether, and we'll talk about that later. In this case, this just says that the number y has to be a 0. That's perfectly good. Going to plug along. Okay, now let's use this to kill this, because our goal, right, is to get zeros above that 1. And so I know that in order to kill the 2, I need a -2. The way to turn that into a -2 is to multiply the entire equation by -2. So I multiply the entire thing. I get a 0, -2. -2 times 2 is a -4. So now I'm going to take that, add it to the top equation now. So what's not changing? The bottom equation. The second equation is not changing, and now the top equation is going to change. When I do this, remember I didn't write the zeros there because I'm not even thinking about that. It doesn't matter what you multiply them by. When you go to add them, it's not going to change those first 2 entries. So that guy is fine. -2 and 2 is 0. That's why we did it. -4 and 8 give me a +4. Okay, I'm going to go ahead and just get these out of the way just because it's kind of ugly. On your paper, you don't need to do that. I just want it to look nice right now. Okay, so the final thing, right? We have zeros here, we have zeros here, we have zeros here. Now we just need to get zeros above that guy. And I'm thinking, well, there's one number that's going to add to that to give me a 0, and that number is +3. Okay, so that means I need to take +3 and multiply that entire row by it. But when I do that, oh, it happened to be a row of zeros, only 1, 1. So we get a 0, a 0, 0, and then that guy right there gives me my 3. I add it to the top, and we get, finally, let's see, this should be our answer. Who's not changing? Bottom row is not changing. Middle row is not changing. Now the top row, I'm taking 3 times this row, which is that, conveniently written it right here. And now I'm just going to add it to the top row. The 0 and the 1 stay at 1, the 3 and the -3 give me a 0 by design. 0 and 0, 0, 0 and 4 is 4. And now that should be our answer, right? Because this means x is equal to 4. This means 0y is equal to 0. 0z then is equal to 2. And that is what we're looking for. And you could take that, plug those back into each of the original equations, and verify that that is indeed the solution to the system. Number 24, this is a 4 by 4, right? And yes, the way we've written it, there are 4 by 5. We understand that when we're talking about 4 by 4, we mean 4 equations and 4 unknowns. And in this case, they gave us W, X, Y, and Z are my unknowns. They're in that order. And I just copied the system in the same way that it was given. right? Because, well, first off, we have a leading one, the way it's written. That's cool. We have a few choices for leading ones, right? And look, I'm kind of going to go on for a second here. We could choose any one of them to start for our leading one, right? We could, if we wanted to, we could have written this equation here and then that equation there. We could have written them in any order, really. But I noticed something that's going to actually help me out. It's going to make matters a little bit easier. Of course, it's going to make them easier now, but if we had done it a different way, it would make things easier at another point. But just right now, I know what I'm going to do first, right? Is I'm going to take this equation and use it to get rid of that and get rid of that and get rid of that to give me my column of zeros. And I just noticed that since this guy is a zero, when I do all that, since it's a zero, that's going to make this calculation part really easy, because it doesn't matter what number I multiply that by. I multiply it by a -2 and I'll have some stuff, and then I'll have a 0. And so then every time I go to add it to another equation, that's just going to be a 0. It's kind of like in the end, right, when we have our reduced row echelon form and we have all these zeros, you know, like we'll have a 1, 1, 1, 1. And when you have all these zeros here, when you go to add them back, you don't even need to think about it. So you don't need to do this, right? The method that we have, right, our algorithm, will work no matter how you choose to arrange this. It's just, I just happen to notice, oh, that's going to make things easier for me at first, which is nice. So, but nonetheless, let's forget all that and let's just do this problem. I have written my system as an augmented matrix. Okay, so step 1 is done. I have a leading one, so step 2 is done. Now, I'm going to use that to kill each one of these guys. Okay, so I think, okay, how do I get a 0 out of that guy? Well, he has to be a -1. Okay, so I would need to add a -1 there. And let's go ahead and make some room right here. So I'm going to do that above and say, okay, if I have a -1 here, then when I add it, that will kill that guy. So then I need to multiply this entire thing through by -1. When I do that, I get a -1, and then I get a +1 with that guy, right? Just multiplying through. -1 times 1 gives me a -1, and oh, my big fat 0, which is nice. Okay, now I'm going to take that, add them to here, and I can see that the same thing's going to work for that one, because that's also a +1, and that guy will work on him too. So that's nice. So since we could knock out those two with that one equation, let's go ahead and figure what we're going to need to add to this guy to finish off the job. And I know that what I add to 2 to make it 0 has to be -2. Since there's a 1 in front of there, I know I have to multiply that entire thing through by -2. When I do that, I get a -2, -2, +2, -2, and a 0. Okay, so let's do our additions. The thing that's not changing is the top row. So 1, 1, -1, 1, 0. A bit more here. Okay, now let's kill that guy. Remember our goal. We want zeros right here in the first column. Kill that guy. I'm going to add that row, -1 times the first one, to that guy. That gives me a 0. -1 and -2 is -3. 1 and -2 is -1. -1, -1 is -2. 0 and -5, don't even need to think about it. All right, now the next row happens to be the same thing. That's convenient. Let's take that, use that to our advantage. We're going to say -1 and 1 is 0. -1 and -3 is -4. -1, I'm sorry, +1 and -1 is a 0. Nice. -1 and 1 is a 0. Extra nice. 0 and 4 is 4. Okay. The last one is to add It's -2 times this row to that row. We've already computed -2 times that top row, so let's just add like this. And I want to say, okay, this is 0. This guy is a -3. This guy is a +1. 3 minus 2 is another +1. 7 and 0 are 7. Okay. Now it's like, hey, we have a 3 by 3 system, right? We know how to deal with that. Now, here's the thing. Like in the beginning, I said we could write this in any order we choose, right? And earlier I chose the last one I did. I said, well, we have a leading one in one of the columns, in one of the rows already. And it was the way the book wrote it was that it was at the bottom. I said, well, just write it at the top. You can switch rows around, no problem. I noticed that this row right here, the same way as I was saying earlier, right? You have a nice big fat 0 here, and that made calculations easy. I also noticed that if I were to turn that into a 1, which I would do by dividing by -4, we would turn that into a -1, which is a nice number. I have a bunch of zeros. I'll have a 1 and a -1. That seems like a pretty nice way of dealing with it. Now, like I said, we could just plug right along. We could just say, well, I need a leading one right here, so I'll divide that by -3, and I'll get -3 all the way across. And then I'd have 1/3, 2/3, 5/3. That I'll be dealing with fractions, and we don't like that, right? Sometimes you have no choice. Sometimes you have to do that. But in this case, I could see, like, well, if I let this be this row, I'll have 1 and then 1/3, 2/3, 5/3. If that were my top one right here, I would have again 1 and then -1/3, -1/3, -7/3. If I let that be the top row, that's what I'm saying is just interchange these two rows, which we can do at any time, then my life might get a little easier. So let's go ahead and do that. I'm going to just rewrite this. I'm going to try to squeeze it in right here because I'm not doing any hard calculations. I'm just rewriting the rows. We have a 1, 1, -1, 1, 0. This is now going to be that row right there. 0, -4, 0, 0, 4. And I could swap it with either one of those that I want, and rather I could write these in any order now. I don't see any difference really, so let's just go ahead and write that one now. 0, -3, -1, -2, -5. And the final row, 0, -3, 1, 7. Now, if you're like, well, I don't know, Justin, you said that the algorithm would say, then we just get a leading one right there. Okay, go for it. We'll get to the same answer. No problem. You don't need to do this. It's just that I've done so many of these, is why I assigned a lot of them, is that after a while, you start to recognize, I know what's going to be easier on me. I know what's going to make these calculations simpler. And so, like I said from the beginning, you could exchange rows at any time. And that's what I did. I said, it's going to be easier on me now because now, okay, now I'm looking at this and I'm saying it's a system. There's my 3 by 3 system, right? That guy needs to be a 1. I need to have a leading one. So I'm going to take that and divide by -4 or multiply by -1/4, however you want to think about it. It's the same thing. So let's go ahead and do that, see what we get. So right here. The top row is not changing. 1, 1, -1, 1, 0. This guy then becomes 0, 1 by design, 0, 0. 4 divided by -4 is -1. Okay. 0 to -3, -1, -2, -5. 0, -3, 1, 1, 7. Okay. Now, okay, so I have my column of zeros. I have a leading one. Let's get our column of zeros right there. Nice. In fact, the same multiplication will work for both of them. What I need to add to that to turn it into a 0 is a positive 3. Ditto for that one. So I'm only going to need to write this once. I'm going to take this guy, multiply him through by a positive 3. When I do that, I get a 0, 3, a 0, a 0, and a negative 3. Okay, now I'm just going to add that to each one of these rows. I'll do that all at once here. So I'm going to write down the rows I'm not changing. That's the top, the first 2 rows. 1, 1, negative 1, 1, 0, 0, 1, 0, 0, negative 1. Now, add that to that row, and we get a 0, a 0, a 0 plus negative 1 is a negative 1, 0 plus negative 2 is negative 2, negative 3, negative 5 make a negative 8. Okay, now let's do it to this row right here. So we have the zeros, 3 and negative 3, 0 by design, 1, 1 plus 0 is 1, 7 minus 3 should be a positive 4. Okay, now let's check how far we've come. We have leading 1, column of zeros, leading 1, column of zeros. Now we're back in this case right here. Now we're just down to a 2 by 2 system. And I could do this in any order that I want. I could flip these rows like we did last time because I noticed, hey, that guy's already 1. I could multiply this through by negative 1 to give me a leading 1 like we want. Let's go ahead and do it that way. We're just going to go ahead and say, and now since I'm running out of room, I'm not going to rewrite this. I'm just going to say, well, if I multiply this by negative 1, it's just going to flip these signs, right? That's kind of the point, right? Multiply this guy through by negative 1, and it's the same thing as just making that positive, and making that positive. Okay, so there's another step, right? I'm being lazy because I'm running out of room and I'd like to have as much of this on the board as possible. So we just did that, right? I didn't bother to go through and write a whole nother matrix right there. Okay, so boom, leading 1, that's where we want it. I could also have done that by just flipping these guys around, kind of like we did back here. We said, well, wait a second, it's going to help us out. Let's flip them. And so that's what we did. Okay, so we're here. And I'm going to say, okay, I have a 1 with zeros, 1 with zeros, 1 leading 1. So let's get a 0 right there. 1 plus what equals 0? Well, 1 plus negative 1 is 0. So to turn that, well, we're going right back to where we came, right? Where we came from. But nonetheless, this is the way I want it. And so I'm going to say, okay, negative 1 times this guy gives me a negative 1, negative 2, and a negative 8. That is what I'm going to add to that row to kill that 0. Let's do that. I'm not changing the top. 1, 1, negative 1, 1, 0. I'm not changing that one. 0, 1, 0, 0, minus 1. I'm not changing that one. 0, 0, 1, 2, 8. I'm changing this one. We'll get a 0 and a 0. By design, 1 and negative 1 give me a 0. 1 and minus 2 is a minus 1. Negative 8 and a 4 is a negative 4. Hello, we're almost there. And now I could just see, well, I could turn that into a 1 pretty easy to make both of them positive, or in other words, multiply the entire thing through by negative 1, which I'm going to save some room. So I'm just going to do that, right? And in fact, if you want to do that, like in your work, that's fine. Like if you have 2 negatives right there, you can go, oh, okay, moving on. But I don't really suggest that. If you want to, that's fine. That's fine. So we're just going to go ahead and do that. So now that was my next step. I didn't go copy the matrix down again, but that's what we have. Okay, now we have a leading 1 or a trailing 1, however you want to think about it. So now I need, we're in reduced use row echelon form. Now it's time to back substitute this guy, right? We're going to substitute this guy back in. So, or in other words, get zeros up here. That's what we're going to do. I'm going to say, okay, get a 0 here. I have to add -2 to 2. But the way I do that is by multiplying this entire equation by -2. So I multiply that by -2, I get a -2. Multiply 4 by -2, and I get a -8. Ah, nice. I'm going to go add that to that guy right there. That'll give me the 0 there. Let's see what else. So I'm going to try to squeeze him in here. I'm not changing the top two. So we have a 1, 1, -1, 1, 0. Not changing the second one. Changing the last one. 0, 0, 0, 1, 4. You see that? Yeah. Okay. Not changing the last one. The only thing I'm changing is this guy. I'm going to take this row, multiply by -2 and add it. I'm not worried about the 0. 0 and 0 give me a 0. This 0 and 0 give me a 0. 0 and 1 stays 1. Now the -2 and the 2 give me a 0, just like I want. -8 and 8 give me a 0. Oh, it looks like we have another case where one of our variables is a 0, right? Because this says if this is wxy, it tells me that y is equal to 0 right there. So that's perfectly fine. We could do that. Okay, now we're going to use the bottom row here to give me a 0 right here. And I'm going to go ahead and erase this because it's just in my way. And I'm trying to save space, which is something I don't want you to do with your paper, but whatever. Okay, so in order to kill this and turn it into a 0, it needs to be a -1, which means I need to multiply that entire thing through by -1. -1 times 1 is -1. -1 times 4 is -4. The zeros are just zeros. I am not even going to write them. Now I'm going to take that and add it to there. So I'm changing the top row and none of the others. So let's go ahead and write that bottom row. 0, 0, 0, 1, 4. 0, 0, 1, 0, 0. 0, 1. 0, 0, -1. Now, take -1 times that, add it to there. It's the same as adding those two numbers here. The zeros just give me that right back. Now, -1 and the 1 give me a 0. And the -4 and the 0 give me a -4. Okay, nice. So, recap. We started with a leading 1 and we got zeros. Then we had a leading 1, we got zeros. Got a leading 1, got zeros, now we're here. Then we went through and got zeros up here. Now we need to work our way back up and get zeros up above there. What's really nice about this, and this one is even easier than you'd think, this is already the opposite of that number. I could just add that number to that. What's even better is that the rest of them are zeros, right? So that's not going to change that. That's not going to change that. That's not going to change that. And that's not going to change that. So I can just go ahead and add that to that right there and turn it into a 0. Explicitly, what I'm doing is I'm saying take 1 times that row and add it to the top row, right? Because that's the goal. We want to get zeros above all of that. So that's what I'm doing. I'm not changing the bottom row. Changing the next one. Not changing this one yet. Don't need to change it, what we want. Now, adding that to that, the ones stay put. Those two ones have not done anything. Adding that to that gives me a 0. 0 plus 0 is that. 0 and 0 stay at -4. Now, there's just one more thing to do, right? We got zeros all the way up. We got zeros all the way up. Now we just need a 0 right there. So the way to do that is say, okay, What do I add to that number to give me a 0? Well, it's negative whatever that number is. How do I get a -1 out of that? Well, I multiply the entire equation by -1. That gives me a 0, a -1, a 0, and a 0. -1 and -1 make a 1. So I'm going to add that to that. It should be our last bit right here. The things that aren't changing are the bottom row, the next row up, and this row right here. And now the final row, right? We took -1 times that row and we're going to add it to that. It's the same thing as adding this to that. So the 0 and the 1 are a 1. Those two come out to 0 by design. That's what we needed. 0 and 0, 0 and 0. And finally, 1 and -4 gives me a -3. Okay, so now finally, to answer this, we're going to say this is the W column, this is the X and the Y and the Z columns. And so this means that W equals -3. This means that X equals -1. That Y equals 0. And finally, that Z is equal to 4. And there's your answer. So we want to check this by plugging this back into the original equations. So these are the original equations for that system we just solved. These were the answers, and now I'm going to check that this indeed is a solution for this system. So I'm just going to plug in these numbers. Let's do the first one first, and it should come out to equal 0 when I do this. So W, it says, is -3. X, it says, is -1. So I go plus X is the same as -1. Minus 0 for Y. Plus Z is plus 4. And I get -3. -1 is -4. This is a +4. Indeed, it does come out to 0. Works in the first equation. Let's check the second one. We get W is -3. Minus 2x is -2 times -1. We get a big fat 0 for Y. And Z minus Z is the same as -4. So we have a -3. That's actually a +2 minus 4 gives me a -1. -4 is a -5. Yep, that's the same thing. Okay, the second one checks out. Okay, now plugging in W, we have a -3. So let's see, -3. -3 times X is -3 times -1. Y is a big fat 0. Z is 4, so +4, and we get -3. Negative is +3, 0 plus 4. We have that's a 0 plus 4 gives me a 4. Check. Okay, last one to check. We have 2W, so that's 2 times -3 minus -1 plus a big fat 0 plus 3 times 4. Let's see, that's a -6 plus 1 plus 12. 12 minus 6 is +6. Plus 1 is 7. This does equal 7, and we are good. So that is the solution to the system that we were given.